Hello, everyone, and welcome to our distinguished guest to a webinar on introduction on non-seismic and non-conventional data acquisition tools. Once again, my name is Eowan Eswa, the Administrative Supervisor of Synergy EMP, and I'll be your moderator for today. At Synergy EMP, safety is first, so please do not drive while attending this webinar. Ensure to maintain situational awareness and always comply with online meeting ethics. Thank you. In this 2 hours webinar, we'll be talking about groundbreaking tools that has changed the trajectory of exploring and producing oil and gas. Thank you for taking the time to join us today. In this high converting webinar, we'll be talking about convenient, effective, and efficient ways of exploration and production in the oil, gas, and mining industry, which is also relatively cheaper than conventional technology. I would like to recognize all our distinguished guests here, captains of the industry, our stakeholders, our partners, and everyone here present. We say a big thank you for your time, and you're important to us. Ladies and gentlemen, we will start with the introduction of our group of companies, our advisory board, and our presenters for today. Thank you.
PANA Holdings is a business platform of unmatched enterprise standards, and with a primary focus on the industries of oil and gas, mining, process, power, industrial real estate, and agriculture. What sets us apart at PANA Holdings is that we dream with a deadline, and we strive to bring to life the difference between a business mindset and the mindset of entrepreneurship. To this end, we combine the multifaceted skills of our international executive team and deliver innovative solutions through our portfolio companies, always driven by sustainability and bearing our seal of excellence. Our portfolio companies include PE Energy Limited, Synergy E&P, AKD Digital Solutions, Kari Care Limited, PE Goldland Industries Limited, and Ataraxia. PE Energy Limited was incorporated in 2009, and it is a leading African energy provider, specializing in engineering, procurement, integration, installation, and maintenance across its growth engines: valves and actuation, measurement solutions, process and power, automation and controls. As of 2023, spearheading the NCDMB initiative to propel Nigerian industrialization, we are entering manufacturing and assembling across our verticals. Our focal markets include oil and gas, energy, power, marine, mining, cement, etc. Exploration and production and digitalization have spun from PE Energy in 2022 to form separate affiliate entities as Synergy E&P Limited and AKD Digital Solutions Limited respectively. The PE Center of Excellence spreads over an area of 10,820 square meters. It is the administrative and industrial hub, fully equipped with state-of-the-art equipment for manufacturing, assembling, overhaul, calibration, recertification of valves, pumps, metering solutions, control panels, instrument fittings, and many more. Synergy E&P is a company with a focus on oil and gas, exploration and production, and solid minerals mining. We operate across Africa, leveraging our global partnerships and our expertise in identifying, adapting, and developing opportunities and technologies that accelerate the energy transition. At the heart of our business stands our purpose for sustainability because we care. Our vision. We aim to contribute to the global energy transition by promoting non-conventional technologies, diversifying our energy portfolio, and remaining focused on environmental stewardship. Our strategic goals. We are intent on meeting the world's growing energy and industrial needs through our operational excellence, innovation, and commitment to sustainability. Our services. Some of our key offerings include exploration through non-conventional patented technologies for data acquisition, data integration, data display, production, related innovative solutions including enhanced well production, oil recovery and produced water treatment, sustainability, driven technologies focused on flare gas reduction, carbon capture utilization and storage, hydrogen infrastructure and storage, overall decarbonization of the oil and gas industry. AKD Digital Solutions is a technology consulting firm that provides digital transformation solutions to businesses of all sizes. With a steadfast focus on collaboration, innovation, and agility, we empower businesses to realize their full potential by leveraging the latest digital technologies and best practices. Our services include consulting, design, development, implementation, after-sales support, and maintenance. Our specialization is digitalization and optimization of operational workflows, creation of organized, actionable databases and dashboards, predictive analytics, safety lifecycle management systems, blockchain-based SCM solutions, etc. We cater to multiple sectors, including oil and gas, energy, financial services, telecommunications, construction, government, healthcare, and enterprise. Our aim: as the business landscape becomes increasingly digital, the operational processes of a company are at the heart of its success. AKD Digital Solutions understands this fundamental truth and is committed to providing innovative digital solutions that optimize business operations and drive overall performance. Our vision: to guide our customers across their digital transformation journey. Our mission: to empower businesses of all sizes to achieve their full potential in the digital world. AKD Digital Solutions, transforming businesses for the digital age. Mrs. Pat Maselli is a member of the advisory board of PANA Holdings. Prior to taking up this role, she was the former deputy director and head of the upstream regulatory division of the recently defunct Department of Petroleum Resources, DPR. Presently, retired. Before ascending to this role, she held and served DPR in several capacities, including Coordinator National Data Repository, Assistant Director Exploration, Assistant Director Domestic Gas Obligation, Assistant Director Resources Management, Assistant Director Work Program and Unitization, Team Lead for Nigerian-Norwegian Collaboration for Monitoring of Petroleum Activities, represented Nigeria in several international upstream engagements, speaker in many national and international conferences. Mrs. Pat Maselli is a member and fellow of NAPE, for which she is currently serving on the advisory board of the association. She is also a member of NMGS and AAPG. Mrs. Pat Maselli is currently the CEO and Managing Director of Marzarin Limited. Mrs. Callista C. Azogu is a member of the advisory board of PANA Holdings. Prior to taking up this role, she was the former Deputy Managing Director of Nigerian Ajip Oil Company Limited, NAOC, a subsidiary of Eni Italy, up till August 2022. Before ascending to this role, she served Eni for 27 years in several capacities in Nigeria and abroad. Her experiences span topmost level industry advocacy, accounting, finance, Nigerian content, human resources, administration, commercial, midstream, and special projects. She pioneered Eni Ghana as the first financial controller, and the company is one of the key successes in Ghana oil and gas industry today. She represented Eni in various national forums, including the Oil Producers Trade Section, OPTS, of the Lagos Chamber of Commerce, an umbrella body for most of the oil and gas exploration and production companies in Nigeria, and Nigerian Employers Consultative Association, NECA, among others. Mrs. Azogu won the award of the first Nigerian Content Operator of the Year for Eni and received the Patan Chairman's Outstanding Achievement Recognition Award for Nigerian Content in 2015. She was also a director of the Nigerian Egypt Closed Pension Fund Limited from 2015 to August 2022. Mrs. Azogu is a fellow of the Institute of Chartered Accountants of Nigeria, ICANN, Institute of Chartered Mediators and Conciliators, ICMC, and a member of the Institute of Directors, IOD, Chartered Institute of Personnel Management, CIPM, among others. Mr. Tipu has an MSc in Geophysics and over 20 years of experience with hydrocarbon exploration, development, and new venture projects in Asia, the Middle East, and Europe, OMV, Schlumberger Western Gecko. He is a professional geoscientist with experience in seismic data acquisition, processing, and evaluation, and in special reservoir studies including AVO, inversion, and seismic forward modeling. Experienced in integrated exploration and production processes, cutting across integrated 2D/3D structural and stratigraphic seismic interpretation. He enjoys the opportunity of mentoring and developing less experienced geoscientists of industry and academia on geophysical techniques. Mr. Rick holds bachelor's and master's degrees from Texas A&M University and the University of North Texas, respectively. He has over 2 decades in oil and gas and environmental realms, and is currently the Executive Vice President of Amplified Geochemical Imaging and a thought leader based in Houston, Texas, United States, overseeing all functions of the company, including manufacturing, laboratory operations, technical operations, and sales. He developed mobile offshore CO2 sensors, a game changer for offshore CCUS projects. He has also worked to develop a 3D profiling of petroleum hydrocarbon systems. He has published over 70 publications over the years and has been invited as a keynote speaker to many national conferences. Mr. Douglas Pitcher holds a bachelor's degree in physics and mathematics from the Memorial University of Newfoundland, an MSc in geophysics from the University of Toronto, Canada, and is currently the International Operations Manager at Techno Imaging, directly involved in electromagnetic, magnetic, radiometric, gravity, and natural field surveys. With over 3 decades of experience in ground, marine, and airborne geophysics, he has developed and coordinated government and private industry surveys on a global basis over a span of 3 decades. He worked as managing partner at Geotech, a Canadian company, West African manager at Fugro, a Dutch company, and executive vice president of Aerodat Limited in Canada. He has co-authored several papers and presented talks on airborne geophysical methods and ground geophysics.
At this juncture, I would like to introduce our Group Managing Director of Synergy AMP, Mr. Dare Akobo.
Mr. Dare Afanya Akobo is an entrepreneur, business mentor, and philanthropist, born in Port Harcourt, Rivers State, Nigeria on May 12, 1973. He is the chairman, Pana Holdings Limited, founder and group managing director of PE Energy Limited, Dare Afanya Akobo Foundation, DAAF, Kari Care Limited, Synergy E&P, etc. Mr. Akobo worked with General Electric GE and International Petroleum of Nigeria, amongst others, which made him excel in the sub-Sahara African oil and gas industry, counting over 23 years of experience. He graduated from Rivers State University, Nigeria, with a degree in applied physics. He is an alumnus of the Harvard Business School, Boston, USA, amongst others. He is a fellow, Institute of Directors, London and Nigeria, and also member of the Forbes Business Council. He received several awards, notably the Tax Compliance Award by FIRS, the Nigeria Super Vendor Delivery Performance Award, the Integrity Award by Shell, and the Outstanding Business Personality in the Oil and Gas Sector Award by the University of Port Harcourt Business School, and many more. He has been described by The Guardian, October 1st, 2018, as one of the top 25 dynamic and influential CEOs. He is married to Iyenemi and blessed with 4 lovely children, Mildred, Eldred, Esmeralda, and Sophia.
We will now take our opening speech from our Group Managing Director, Mr. Dare Akobo.
Thank you, Ayoan, for wonderful job you are doing. I will stand on existing protocols, but I want to thank all our guests here, industry captains, geophysicists, and also our esteemed advisory board and our partners and speakers of this event. My name is Dare Akobo. We are here to solve just very basic problems, as it has been, repeatedly shown on the videos and then the voice intro. The company Pana Holdings is here to solve, particularly for this section, to solve the demand of the world, the society. And that is ranging from energy security and all the way to energy transition and, zero carbon or carbon emission. But I will call it greenhouse emission because it is not only CO2, we're talking about methane and so on and so forth. However, specifically, this seminar is also addressing some of the sections of the Petroleum Industry Act, especially where the Commission is tasked with a commercial requirement to review and approve commercial aspects of the field development plans in both the upstream and also, of course, that consists of the marginal field operators, independent operators, and sole risk, and of course, JV operators. However, we are not here to reinvent the wheel, but what Synergy E&P does is actually to, have what is called technology stack. And this is because we have discovered that there is no democracy in data, and there is no democracy in, novel technologies. So we took it as upon ourselves in 2018. I personally wrote to Mr. President, the former President of the Federal Republic of Nigeria, President Muhammadu Buhari. I personally took interest to write to him, and that gave an opportunity for a young man with that aspiration to help the nation to improve a technology, NXT energy solution with a novel technology called of the SFD. That technology was tested with the then defunct Department of Petroleum Resources, and we notably had results. And that has resulted into the current, boost and the current confidence that the government has placed on the technology to drill the Kolmani discovery. Also, it is pertinent to mention that the PIA mandates the commission to develop cost-cutting studies, evaluation, and also to look at what are the various attributes that technology can bring on board to actually reduce or to address critical industries challenge, such as petroleum, exploration success. You may be aware that in 2016, the Financial Times of Wood Mackenzie actually published that the success of onshore exploratory activity is about 18%, leaving 82% failure rate. And that is for onshore. And then for offshore, that's about 7% success rate and 93% failure rate. So the probability of success is what we are trying to increase. And one of the ways we want to increase that is to bring a suite of technology that we are not originally talking to themselves, but they are complementary in nature to be able to reduce or to de-risk your existing asset. What that means is that before you spend, and recently was discussing with the commission, before you go into drilling, before you want to do anything, although we're going to attack the wildcat, we're going to talk about the acreages within the Delta Basin and the Niger Delta Basin. But this stack of technology will enable you to reduce the failure rate. It will reduce the failure rate and increase the chances so that you can actually focus on drilling operation. So I'd like to welcome everybody to this seminar. And it is something that we are doing for the first time in the history of Federal Republic of Nigeria. And I believe that it will be told for contemporary history, and it will be apt for humanitarian appetite. I hereby declare this seminar open, and I would like the presenters to do the needful. Thank you, Ayawan. Back again to you.
Thank you very much, sir. At this point, we would like to go into the presentations proper. To ensure that we are helping you as best as we can throughout this webinar, we have a chat box to collect your questions. The chat box is located at the right top corner of your screen where you'll see the Q&A sign. Please feel free to drop your questions on the topics or share your struggles or experiences. Our team of experts will be answering all your questions by the end of the presentations during our designated Q&A session. Also, this webinar recording will be available later on our YouTube channel, Synergy E&P, just to help everyone keep up and understand properly. Our guest speakers for today are Mr. Rashid Tipu, who is the Director of Geoscience NXT Energy Solutions, Mr. Rick Srinamikas, the Executive Vice President of Amplified Geochemical Imaging, and Mr. Douglas Pitcher, the International Operations Manager of Techno Imaging. We are definite that marginal fields have upside potentials which hitherto was not identified by the use of 2D, 3D, seismic, and other conventional acquisition and integrated methods. We're also confident that this webinar will showcase the value that these carefully designed combination of technologies offer. So let's get started. Our first speaker is Mr. Rashid Tipu of NXT Solutions. Over to you, Mr. Rashid.
Thank you very much. Good day, everyone. And thank you very much, Synergy ENP team. And my name is Rashid Tipu. And also I will be assisted by Mr. Muhammad Saqib, who will be giving a quick introduction on the technology. And then I will be presenting on some of the technical case studies and also the integration results. Over to you, Saqib.
Okay, thank you, Rashid. So NXT is a Calgary, Canada-based geophysical survey provider who owns and deploys the patented SFT method for prospect scale upstream exploration and development. The technology was commercialized in 2007 and since then has been used by a large number of clients, including a number of repeat clients in the United States, Canada, Mexico, all throughout South America, as well as Asia and Africa, including Nigeria. On the right-hand side of the chart there, we can see a selected list of the companies that NXT has worked for over the years, including British Petroleum, Pemex, which is the National Oil Company of Mexico, YPFB, which is the National Oil Company of Bolivia, PPL, the National Oil Company of Pakistan, and NPC, the National Oil Company of Nigeria, and a whole host of other medium to large scale independents. Next slide, please, Rashid. So the underlying premise of the technology is the identification of a specific subsurface condition associated with the combined presence of density homogenization and horizontal stress reorientation, which are strongly indicative of non-hydrostatic trapping conditions. It achieves this by using the principles of quantum mechanics to achieve a sensor design that allows coupling with the gravitational field at the field level as opposed to the commonly recognized force or mass interaction. By doing so, it offers an independent lead identification method, which can be utilized in conjunction with other GNG methods, notably 3D seismic, to fast-track upstream exploration and prospect development. The validity of the method has been proven by the drill bit over the years. 28 SFD prospects that have been recommended by NXT have been drilled post-recommendation, 19, of which 19 have proven to be successful, yielding an average prediction strength of approximately 64%. Right, so this is basically getting into a little bit of a detail about the NXT technology, which is how the instrument couples to the underlying stress field. So on the left-hand side here of the chart, we can see an example which is taken from the Joshua Tree Fault in the United States, where we can see where the author studied the effect on the gravitational potential of the underlying stress change in the fault. And as we can see that the gravity gradient, the solutions to the gravity gradient closely mirror the solutions of the Coulomb stress changes in the subsurface. And the author goes on to conclude that given an instrument of sufficient resolution, it would be possible to approximate the stress changes in the subsurface using the dilatational gravity gradients. In a similar example at a slightly different scale, which will be shown on the right here, is an example taken at the much greater Moho level over the Indo-Pak subcontinent in Southeast Asia, where a similar effect was studied by the authors, and they go on to show that the horizontal and vertical components of the gravitational field approximate the stress changes in the subsurface. So two different examples which highlight how the gravitational potential is impacted by the underlying stress change at different levels, one at the fault level and one at the much greater lithospheric level, highlight this important relationship. And this is the underlying premise of the SFD technology. Next, please. So the SFD technology has been patented in 46 countries around the world, including the United States, Canada, Europe, Japan, and a number of significant other economies around the world. Apart from the primary function of protecting NXT's intellectual property, the patent highlights the conceptual novelty of the method and serve as an independent review of the underlying physical concepts and deployment principles of the technology.
Okay, on this slide, what we are trying to convince, as Mr. Daire Kubo, he mentioned on the complementary technologies with existing oil and gas upstream explorations or development algorithm. Like on the screen, what you can see, this is a conventional method where we geoscientists normally look for area where you can have a proven source rock or have a reservoir potential, and also the migration happen. So then we collect a lot of data set, like especially the 2D 3D seismic, some reconnaissance tools to see the structural type of the area, and then we identify the leads area, and then we do the pre-drill risk assessment through different geological and geophysical studies, and based on geological chance of success, we drill the well. As it was mentioned earlier by Mr. Daire Kubo, the chance of success as of today, it's around 18%. So when you are bringing in SFD technology, like a complementary tool to existing exploration workflow, which respond to the subsurface discontinuity induced by density and stress variation in and around a geological feature conducive to fluid entrapment. The sensor detect, in fact, the stress regime in a horizontal plane, so that you can see that it's a complementing to the existing workflow and its increased chance of success. To date, like our client mostly utilize our technology in a different exploration cycle, like from a frontier area where you have a limited data set, and over a large area, they acquire SFD and then go from there to focus over a potential prospective area by acquiring a focused 2D or 3D seismic. Or if in a few areas, like in Nigeria also, when we did a survey, so there was an area where they were planning for the seismic, and there was a planning for drilling a well. So like if you could have an area where some of the areas were already evaluated through other geological and geophysical data set, and we fly over those prospective areas and then recommend what drill or not to drill, which is, we call it prospect confirmation. So by doing so, we also are very well used in different areas for near field or marginal field areas to identify upside potential of already producing assets.
This is a summary of the deployment of the SFD method. The sensors are installed on board a Cessna Citation 5 aircraft, which is flown at about 3,000 meters above ground level at about 500 kilometers per hour. There are 24 independent sensors on board, which serve to reduce the uncertainty that is associated with quantum instrumentation and methods, and allows data stacking for increased confidence at the interpretive level. The nominal sampling rate of the SFD sensors is just about 2000 hertz per second, which translates to a centimeter level resolution at the ground, over ground distance. The SFD method can consequently, because of the acquisition parameters, be deployed over any kind of geological setting, including onshore, nearshore, offshore, and so on and so forth. Because of the acquisition height, it has very little surface impact or very little community impact, and therefore it makes it an ideal first pass reconnaissance tool for all sorts of upstream exploration. Next, please. So in this slide, we illustrate two primary aspects of the technology via an example data set that was acquired in the foothills of Colombia in the Llanos Basin. Two fields have been selected along this flight line for demonstration. The one in the north is the Cusiana oil field, which is a classic asymmetric hanging wall anticline trap located in the deformed belt of the Eastern Cordillera. And the one in the south, or approximately halfway through the flight there, you can see, is the giant Rubiales heavy oil field, which is a hydrodynamic trap in the forebulge of the basin, formed due to the intersection of the top seal and a tilted oil-water contact. So firstly, we note the signal attributes which contribute to the anomaly identification. most notably the standard deviation, the amplitude change, and the frequency change, which are largely similar to any other geophysical data set. What this shows us, with respect to the completely different geological nature or the trap setting of the fields, is that the SFD technology is trap and fluid type agnostic, as illustrated by the wide variation in the geology and the setting of these two oil fields. The Cusiana oil field is a light oil field and associated with condensate gas, whereas the Rubiales field is a very heavy oil field, which is flowed through steam-assisted operations. So again, this shows that it is the subsurface setting that contributes to the anomaly as opposed to the exact fluid or the exact type of trap. Secondly, and most importantly, the data interpretation on SFD does not require any pre or post modeling, and it has no dependence on any other data sets, which allows for a rapid and effective identification of areas that are conducive for trapped fluid. Next, please. Now, this slide illustrates a final deliverable or end product of the SFD survey, which has been performed in a grid pattern. This pre-bid data was acquired over the shallow water Gulf of Mexico blocks, during which 50 transects covering more than 20,000 line kilometers of data were acquired in just under a month. So this illustrates the extremely rapid pace at which SFD data can be acquired and interpreted, and the output mirrors that of other geophysical technologies to a large degree. The data was interpreted and the resulting SFD prospectivity indicators were contoured. The cool colors indicate areas of low prospectivity, and the warm and the hot colors indicate areas of primary exploration interest. The yellow colored boxes on the top, the ones that are filled in with yellow, for example, the Pollock, Chinwol, Saskin, and Hokchi fields, they indicate discoveries that have been made after the SFD survey was performed, thereby confirming the prospectivity indications, chances of success as indicated by SFD. The ones that are not filled in, the black colored boxes, the Zama, Cholula, and the Zulum fields, were basically pre-existing discoveries at the time of the survey. And in either case, the discoveries, whether pre or post, serve to indicate the efficacy of the technology in identifying and recommending areas that are most conducive for trapped fluids. Next, please, Rashid.
Okay, thank you. So NXT was engaged by Frontier Exploration Services back in 2019, and we acquired 5,000 line kilometer in April to May 2019, which was almost 18 days. We acquired 5,000 line kilometer. And then final SFD results were interpreted, a part of that in Nigeria, and also then the interpretation was done in Calgary, Canada, over head office. And then we did a joint integration study with the Frontier Exploration Services geoscientist and the management team, along with the DPR, which is now NUPRC representative, and also some of the producers in that area, which is they were there. So we, in fact, based on, as Mr. Daire Kubo, I will refer again, he mentioned like one of the primary objective for this SFD data acquisition was to see the potential of inland Nigerian inland basins, which were kind of underexplored, and were look back. If we look back in 20 years or more than 20 years, then there was limited seismic data. A couple of 3D seismics were acquired, and there were some of the area where there was oil or gas shows were happened in past, but there were no further development or explorations work was done. So based on the over entrance, and I think Mr. Daire Kubo mentioned about the approval of SFD technology, we were given a task, which is two flight lines were acquired over Niger Delta offshore region. And you can see on the pictures, like where we were also training our local geoscientists in Nigeria on stress field detection technology. It's a methodology, interpretation, and integration. And on at the left bottom, you can see that the thumbs up picture where we got after integration of SFD results with available data set at NUPRC office. And on the left hand side, we see a letter where it was recommended like SFD technology can be used in oil and gas exploration and activities in Nigeria. So this is SFD attributes and profile from Kulmani River area. And as you can see on the left-hand side, there is an area of interest, what we recommended based on SFD signal attributes. And we recommended it, and then this results were integrated later on with the seismic. As you can see on the seismic, there is a Kulmani River structure on the right-hand side on the upper corner. You can see a strong seismic amplitude reflection on the section and interpreted as a three-way deep closure anticline structure. So that's where we can see, the signal attributes and versus seismic attributes, they are correlating very well. However, worth to mention that back in 1986, Shell drilled first well, and it was P&A, and then they drilled a delineation well in the same year towards northwest part of the area, and it also only shows the gas. Whereas on SFD recommendation, you see that pink bar, where we are recommending, the more prospective area in the Kulmani area is more on the southeast rather than the northwest, and that's where the well number 2, which was drilled by Frontier Exploration Services, came in back in 2020, and it is on a press release as well. So I'm going to showcase the Colombia. So similar case, like we acquired one of the survey for our client in Llanos Basin, Colombia, where they have existing producing assets, and they were looking for upside potential in nearby areas. And we flown over, and you can see, which was already presented in a previous slide, Rubiales field signal. And then our recommendation back in 2009 in a red box and attribute, which is very similar to the Cusiana field, the Rubiales field. And it was drilled ultimately and developed, and you can see, and if I will flip between 2009 and 2016, and as we can see, it's really giving you a near field development, or to see our recommendation was drilled, and it was become another producing assets in 2016. So Gulf of Mexico, this is another scenario where we flown over, and we recommended the areas where it was 2 wells were already drilled, and they were dry and P&A. And so SFD recommended the area more prospective in that domain where it's already 2 dry wells were drilled. As in previous slides, we were presenting, the SFD technology is recommending regardless of the structural or the trap type. It could be structural or it could be stratigraphic, and it's purely based on the fluid entrapment potential. So those wells are. So this is just a seismic for illustration purpose. It's a trap which is assumed as a system of normal fault block with faulted orientation northeast and stratigraphic closure to the south. It's a salt driven structural type. So this was also drilled, and back in 2017. So this survey was done in 2012, and it was drilled in 2017. It came up with Goricho, Ayacucho, Licanto, Calicanto. So these are the assets. So this is another interesting where we did a survey with the YPFB, Bolivia. And over here, it's I'm going to explain a little bit on signal attributes and also the independency of SFD technology and the complement part of SFD technology with existing geological and geophysical data. So we were acquiring a survey in Bolivia where they were already planning to drill a well, and the rig pad was ready. And if I will start with first with the geophysical point, so you can see a structure map, and it's a perfect fault bonded structure, and we can use it as a minimum, like a red is where you have all the maximum and the minimum closure contours. And we were asked to fly over and give us a field interpretation right away, because SFD technology can provide brute stack level interpretation within 2 to 3 days, which can help to even mitigate or to evaluate if you are doing some drilling decisions, or you want to see like really you want to go for which or where you want to place your budget for the exploration or the development well. So we flown over and we show a signal attributes based on purely based on SFD, and we can see there was hardly any attributes, as you can witness previous slides where you can see all the signal attributes, which is very strong, and it also very pronounced. And you can see it's a U-shaped, it's like a trough bonded by two peaks. But over here in Bolivia, we showed them we don't have any attributes. However, they asked us for another signal from one of the flight. We show that, and we told them, which is on the upper left corner, we said, yeah, we can see some attributes still, but it's not that great. What we learn during integration, the well in the south, which has a signal up and on the upper left corner, it was a 9 BCF single well, which is touching the maximum closing contour of the structure. And it makes sense, they were drilling a well close to the, the best part of the structure, where SFD cannot see any signal attributes, and we cannot recommend it as a potential prospective area to drill. So however, this well was drilled because the rig pad was there, rig was already moved in, so this well was dry. So this is like a perfect scenario where SFD can really mitigate a risk, especially if you are working on a marginal field areas and area which is heavily populated with the fields, and then you want to see where you want to really invest into a next well or next investment. And similarly, like you see in the Kolmani River area, where we've flown and we recommended the area which was kind of abandoned since 1986, and it came up as a success in 2020. Thank you very much, and we will be available for the question at the end of the presentation.
Thank you very much, Mr. Rashid. Thank you to the entire NXT team. I think it's a thing worthy of note that the NXT Energy Solutions offers a unique geophysical service to the upstream oil and gas industry using its proprietary gravity-based stress field detection remote sensing survey system, to help rapidly identify and rank prospect level leads, which also provides the clients with the incomparable benefit of targeting their exploration efforts. I mean, it's quite an interesting thing to note, and it's quite an interesting presentation. So thank you very much. Next, we'll just go straight into the next presentation. And our next presenter is Mr. Rick of Amplified Geochemical Imaging. Over to you, Mr. Rick, please.
So thank you again for being here, everyone. I think our presentations today, as you've already seen, are going to provide you with some powerful techniques to optimize your field development. And so let's talk a little bit about the technology. I assume you can see my screen and the changing of the slides, yes? Okay, so in the illustration, you see the green represents reservoir. The blue line on top of that represents a seal. And then the brown bar to the left of the reservoir represents a fault. And the yellow dots represent hydrocarbons, be they gas or liquids. And so the size of the yellow dot represents the amount of leaking. So we're all familiar with macro seeps where you have leakage along a fault. The hydrocarbons transpire or transport up that fault and terminate near surface, and you see surface expressions of those. What we're probably less familiar with is microseepage. Microseepage occurs by a completely different mechanism. You have, instead of flow of gas or liquids, you have individual molecules of hydrocarbons that accumulate beneath the reservoir seal, and that's methane, ethane, propane, all the way out to C20. And then the pressure in the reservoir drives these individual molecules, as you see on the illustration on the right. You see these individual molecules that move along the grain boundaries and microfractures in that reservoir, and they push through that seal. And once they're through that seal, they then can migrate to the surface through microbuoyancy. And this enables them to migrate to the surface. And the good news is, if you can detect those, they're reflective of what's directly beneath them. Unlike a macro seep, which are off structure, these are directly over their structures and what they're looking for. The bad news is now you're not talking about percent levels or high ppm levels. You're talking about low part per billion levels or high part per trillion levels. So you need a way to be able to monitor that. Now, what drives microseepage? This is really important for the presentation. 3 things: pressure, porosity, and net pay thickness. In other words, all those things are great reservoir characteristics. So the stronger the pressure in the reservoir, the stronger the signal we see at the surface. The better the phi H, or the porosity and net pay thickness, in other words, the bigger the volume of hydrocarbons, the stronger the signal we see at the surface. And so you're going to see in the case studies how this relates to what we're doing. So how do we deploy these modules? It's very easy. We drill a hole in the ground that's about 2.5 centimeters in diameter. It's about 0.5 meter to 1 meter in depth. And then you can see that we use that steel rod. In this picture here, we use the steel rod to insert our module to hang into the hole so that it hangs there. And then we cover the hole with a cork and leave it there for 21 days. The benefit of that is that you see on the inside of this module, you can see a picture of the module down here at the bottom next to this glass vial. On the inside of this are specially engineered polymers that absorb hydrocarbons from C2 to C20. So what happens is, as we leave these in the ground for 21 days, you get this constant flux of microseepage of hydrocarbons to the surface through a steady stream. As they move through that outer membrane, which is microporous or semi-permeable, all that means is the holes are so small that only gas vapors can go through. No water, no soils, no particulates. So as they move through that membrane and they concentrate on those sorbents within, it eventually comes into equilibrium with the surrounding matrix, the soil. And so you get a very stable, accurate, and reproducible reading of what hydrocarbons are directly below it. That allows us to monitor these projects as best we can. So here's a list of the compounds that we look for, a total of 86. It starts with ethane at C2 and then goes all the way to pristane and phytane at C19 and C20. The individual compounds are not as important as the fact that we measure all the way from C2 to C20. That's important because it allows us to see and differentiate different hydrocarbon signatures. So look at this gas signature, a condensate signature, and an oil signature. Those definitely are different. And why is that important? Because even in stacked pays, as you'll see in one of the case studies that we're going to share, we can monitor different hydrocarbon signatures. We can even differentiate 2 different oil signatures that are in different parts of the reservoir. So one of the questions I had when I started with this company many years ago was, okay, how fast does this micro seepage thing work? I mean, are we talking thousands of years or 10,000s of years? Actually, the answer is shocking. The rate of micro seepage averages probably about 2 meters per day, amazingly. And so what that means is it's basically reflective real time of what's in your reservoir below. So here's a case study that was done by a university. This was not done by us, so this was independent. And there was a gas storage reservoir in the United States called the Kyoto Dome Reservoir. Get that off my screen. Stop it. Anyway. Sorry about that, folks. No. Okay. So, sorry about that. Technical difficulties always. So in this gas storage reservoir, it was only 300 meters deep. During the summer, they would restock or recharge this gas storage reservoir, and then during the winter, they would use it to heat their homes. So the red represents they were only measuring ethane. The red represents high concentrations of ethane. Orange is moderate. Yellow is low concentrations of ethane. And then the white areas indicate no ethane detected at all. So you can see in July, there's only a small amount of ethane in this northwest corner. 3 months later, they've begun to continue to charge this reservoir. Now you can see a buildup in October, only 3 months later. 3 months later, but you can already detect at the surface a change in the reservoir below. Then by the time they get to January, they have a reservoir that's completely full of natural gas. And then when they get to April, 3 months later, it's completely empty because they've depleted it, pumping out the natural gas for heating of the homes. So what this shows in this example, the rate of micro seepage to the surface was 3 meters per day. That's very fast. We don't normally see that, but we do normally see 1.5 to 2 meters per day. So the takeaway message from this is what we measure at the surface is reflective of what's going on in your reservoir, essentially real time. So what we're looking at here is a design for a typical marginal field design. The blue circles represent where the modules are in the ground. The spacing between these modules are typically anywhere from 250 meters to 500 meters. And then we also put modules around known wells. In this case, a known producing oil well with a strong pressure and a strong hydrocarbon charge. We've done the same thing around this gas well. And then we do the same thing around a dry or depleted well. The reason we do that is that gives us the signatures that we want. So the dry well signature gives us baseline where you don't have a strong hydrocarbon presence. And then modeling around the producing wells gives us the other end member of what is a strong hydrocarbon, or in this case, strong oil signature. So then we use the oil signature and the gas signature as end members, and we can do a contour map over your field and show you where you have high prospectivity for oil. Or we can use the gas end member and construe a completely different map for the natural gas that's present and do that for you. So there was a company called Santa Fe Minerals several years ago. They used us over a 7-year period. And the technical director, Dr. Robert Potter, he published these results in the AAPG Memoir 66. And they did 139 surveys with us over a 7-year period. That was 33,000 soil samples. And they did both onshore and offshore sampling. And so they drilled, after our surveys, they drilled 141 wells. Of those 141 wells, 98 were drilled over what we showed to be positive hydrocarbon prospects. Of those 98 wells, 16 were quite significant shows, 37 were economic shows, 37 were marginal shows, and only 8 were dry holes. So it correctly predicted where hydrocarbons were in 92% of the wells. They also tracked how we did in drilling over what we predicted as dry holes. And so of the 43 wells drilled over what we predicted as dry holes, 41 of them were dry, one barely had a show, and one was no payout. So I want you to stop and listen to what I'm saying here. Our technology is so sensitive that if we say there's not hydrocarbons there, there really are not hydrocarbons. We saved this company hundreds of millions of dollars over that 7-year period by not drilling dry holes. And when wells cost anywhere from $1 million to $10 million onshore, that saves you a lot of money. So another company called, what was the name of this company? I forget, forgive me. It was a project in San Jorge Basin in Argentina, and they drilled 164 wells based on our data. Of those 164 wells that we predicted, 121 of them were economic, 21 of them were marginal producers, and only 9 were plugged and abandoned. So we had a 94.5% accuracy in predicting dry holes. And this company also got to the point where after the first year or two, they basically said, the technical director said, look, we're using our 3D seismic in conjunction with this, but if the 3D seismic says, oh, there's this beautiful, sexy structure here, but there's no geochemical anomaly over that, we're not drilling we're not drilling there anymore. I don't care what the seismic says. So they were able to reduce their finding cost by 57% because by the end of this period, they were seldom drilled a dry hole anymore. So it dramatically increased their production and also dramatically reduced the money it cost them to do their marginal field exploration and expansion projects. So I'm a visual person, so let me share some case studies with you if I can. This is a project we did in Western Siberia. And we did a project in the Yorudskaya uplift, and it was a gas condensate field. We did a survey over that. The results were very positive for the client, and the wells that they drilled showed them that they tested that they had 4 million cubic feet per day of gas condensate. So they liked the results so much, they then went on to an area not far away called Shuganskaya, and this was 2 years later. And so they had already reprocessed some 2D seismic data, and they decided they found this beautiful, sexy structure, and that's where they wanted to drill their next well. And that top of that crest of that structure is indicated by this yellow star here. The problem with it is, you can imagine in Siberia, there's only like 3 to 4 months out of the year that they can drill because of the extreme weather. So they wanted to make sure that they were drilling in the right place. So each one of these blue diamonds shows you where we put a module in the ground about 0.5 meter to 1 meter deep. The spacing between most of these was 1 meter distance. So remember we talked about the modeling wells? Well, the closest dry well was just north of the field. So we put modules around that. And unfortunately, the closest positive condensate well was 30 kilometers away. So we used that. We were a little concerned that it was so far away, but that was the only option we had. Once we looked at the data, we generated a map for them. The red represents an 85 to 95% probability of finding gas condensate in that area. So this is the gas condensate signature. And so where you have the red, that's where we show gas condensate. Unfortunately, the client wasn't very happy with this. Look, the red represents very high probability, the green represents moderate, and the blue represents do not drill here. So you can see right where the crest of the structure is, we're showing that there's no gas condensate signature. The client was not happy with that at all. When we said, well, we're not finished with the data, that was just the preliminary result. And so what we do with all the projects is we do a cluster analysis. That's where it groups all of the sample data, all of the hydrocarbon signatures by similar signatures. And so the x-axis is C2 to C20. So red represents a strong signal, blue represents a very weak signal. So you can see we had, in this group of samples here, which is about 20 to 25% of the samples, strong red signatures from C4 to C10. That's a condensate signature, and a little bit of oil down here. And this is the average signature for all those samples. All of these blue samples, that was the average. Those were the baseline signatures. Those were don't drill here, and you can see nothing but a little bit of gas. But what was shocking was, look, about 40% of these samples have hydrocarbons from C10 to C20. That's an oil signature. And so when you look at this, this is the oil signature, the average oil signature that we saw. That is very clearly not the same signature as gas condensate. And that's the beauty of this technology. Since you're measuring from C2 to C20, you can clearly differentiate multiple hydrocarbons signatures from stacked. And so when we mapped the oil signature, look at this. It's right over this beautiful structure that they have here. Well, the client still wasn't happy because he said, look, you understand, this is a gas condensate field. Oil has never been discovered out here, so we're going to drill on that structure anyway. We don't care what your data says. Well, they did care a little bit because they drilled deeper than they normally did, and they ended up finding that they had hit oil in a Middle Jurassic section at about 3,000 meters, and they actually had the well test at 300 cubic meters per day, or basically 1,880 barrels per day of oil. They calculated that they had found 340 million barrels of oil in this field. And our technical director looked at their map on Google Earth just about a month ago, and where they now, when they first started with one well, they have something like 25 wells in this field and are still going strong. So that's the beauty of being able to map multiple hydrocarbon signatures. And let me point out something here too. On the left, here's the oil map. You can see that the oil anomaly resides right over that structure and goes from north to south. Look at the condensate structure though. That's in a different place. It's to the west of the crest of the structure, and you still have this north to south trend. What that's telling you is you have stacked pay. If those two signatures had been in the same reservoir, they would have been on top of each other, one right over the other, but it's not. The fact that they're offset indicates or infers that you have two different reservoirs at two different depths. Now, we can't tell you at what depth these are, but we can tell you that they're in different reservoirs or infer that. So let's look at another case study. This is the Anadarko case study. It's the Anadarko Basin, and it was in Oklahoma in the United States, and they were focusing on the Pennsylvania Red Fork Channel sands at about 14,000 feet. That's roughly, what, 4,500 meters, I believe. It was a gas condensate signature here, and what was difficult here was they had quite a few stacked pay intervals in this section. They had basically a Paleozoic section, carbonate sections, Devonians, and so they had charged sections in the Pennsylvania granite wash, the Cleveland sands, and other areas. So they were worried, can we differentiate these other oil and gas signatures from these gas signatures? And indeed we could. And this is the map of what was generated. The gray here represents the area outside the survey. The yellow is inside, or the purple line is the survey boundary. Yellow represents basically non-detect or non-prospective areas, and the blue represents very strong prospective areas. So when I first saw this case study, I noticed all these production wells that are in the yellow area. And I went, wow, we didn't do a very good job there. I mean, look at all these production wells that are in the yellow area where we say they're non-prospective. When I talked to our technical director, he goes, calm down, Rick, it's okay. Those are actually old depleted wells. They're either dry or they're only pumping a few barrels of oil per day. The light blue production symbols are all the wells that were drilled after the survey. So you can see most of these wells were drilled based on our results inside the red area. So what we know is that they drilled 30 wells after our surveys. Of those 30 wells, 22 of them were in what we said highly prospective areas, okay? Of those 22 wells, 21 of them were commercial discoveries. They only had one dry well out of the 22. Out of the 8 wells that we said were over non-prospective or very low probability areas, 5 of those were plugged and abandoned, 1 was non-economic, and then there were 2 gas discoveries. So what that tells you is that 27 out of the 30 wells were drilled correctly. We correctly predicted them. So the data had a 90% chance or 90% accuracy of predicting where positive prospectivity was in their field, even in channel sands, which are really tough. I mean, those are subseismic. You don't really get great imaging from seismic data on those, but we had a 90% probability or accuracy. This was a data we put together with the client's help, and he plotted our probability factor. Remember, I told you that the stronger the responsive pressure, the stronger the probability factor we get. So as you can see here, for us, anything of a 50% probability factor or lower is typically a low producing well or a dry well. And then as you move up from there, so on the y-axis is our probability factor. On the x-axis is what they said they had information for the porosity, the net pay, phi h across the field. So you can see as you get to very low porosity here on the left-hand column, all of those dry wells have a 55% or less probability according to the geochemical survey. As you increase the phi h just a little bit, we get some wells there that are in the 55 to 60% probability factor. And notice that's also where they're changing from dry wells to production values of about 1900 or 2000 MCF per day. As you increase the net phi h to the mid-range here of about 10%, now you're getting probability factors of 70 to 75%. The production from these wells around 5,000 to 4,500 MCF per day. And then as you get into the higher, you get higher probabilities, you get higher production. So this shows what we talked about in the beginning, where you have microseepage, where the stronger the geochemical influence, in other words, the stronger the pressure, the phi h, the stronger the signal we get, and it directly correlates to better production. And you can see here, this one instance where you have 300 MCF per day, and we had a 75% probability. What we think there is they had a problem drilling the well, and they probably still had a lot of pay behind the pipe that they just weren't accessing. So let me go on to our final case study, and then we'll bring the plane down. This was a project that was done in Lithuania. It was a Baltic syncline. They had production in this area for over 100 years, but they were not able to really significantly tap into this production. So the producing horizon was about 2,000 meters deep. And so we did a survey with 150 samples over a 20 square kilometer grid. So here you can see the results of the survey. Again, remember, the red is a very strong 85 to 95% probability. The yellow is about a 75% probability. Green is moderate, and the blue and the gray is don't drill here. Well, this was their production before the survey. They had a couple of wells. Well, G6 was 160 barrels of oil per day, and G18 was 120. So here's well G6. It's right on the edge of the red and the yellow. And then G18, you can find that well right here. It's right in the green area. So the data is correctly predicting that these two should be fairly good producing wells, or moderately. But look at G7, or excuse me, G11. We say that should be dry. Well, G11 is in the blue area. G13 is dry. It's in the blue and green area up here. And G14, that's in the blue and green area. So before we even knew anything about the production, our data is correctly predicting why they're not getting production out of the field. We could answer that question for them. So as a result of that, they then drilled 3 wells right in the heart of the red anomalies that we planned for. Because remember, those are the areas where they have the best reservoir pressure, the better porosity, and the better net pay thickness, and the biggest hydrocarbon volumes. They drilled there, In all these 3 red areas, and well, PS2 generated 3,300 barrels of oil per day. PS3, which is right here, generated 2,000 barrels of oil per day. And then PS4 generated 760,000. The result of that was the fact they had a 16-fold increase in production. And I'm not going to go over this graph, but it's the same kind of graph that you've seen before. Our probability factors on the x-axis, their production on the y-axis. Wells G13 and 11, which are dry wells, we only show a 20% probability, and then you gradually get an extrapolated curve to PS2 and PS3 with a very high production. This geochemical study was later published by the client at a conference in Europe in the 63rd EAGE conference, and they said the results demonstrated that it's possible to use surface geochemistry to determine reservoir sweet spots within a producing field, and that it had a 0.96 correlation coefficient. And he said, so in consequence, it's possible to accurately predict subsurface reservoir quality variations with surface geochemistry. Those are his words, not our words. So with that, I'd like to thank you, and that is the end of my presentation.
Thank you very much, Mr. Rick.
It's stuck.
Hannah
And
Holden.
that's just a summary of what I've already shared with you already.
Thank you very much, Mr. Rick. It's quite insightful that this technology provides expert detection and mapping survey services for the oil and gas, environmental and mineral industries. I think at the same time specializing in ultra-sensitive surface detection and mapping. It's quite insightful, and it's a good thing to note that this technology surveys, identifies, measures, and also maps volatile and semi-volatile organic compounds in soil, gas, water, air, and sediment. It's quite the technology, I must say. So thank you very much for that lovely presentation. For our guests who joined us mid-presentation, we'd like to say thank you for joining us today. And this presentation will be available on our YouTube channel for further learning purposes. And I can assure you, you would not miss out on anything. Please don't forget to leave your questions in the chat box or the Q&A session box, as they would be addressed shortly. Thank you. Our next presenter is Mr. Douglas Pitcher of Techno Imaging. Over to you, Mr. Douglas.
Thank you very much. I know our audience has listened to 2 excellent talks today, and I need about 20 minutes to give you a brief overview on what our company has to offer, called Techno Imaging. First of all, thank you very, very much again for allowing us to give this presentation, and I hope that we offer some insight as to what can be done with existing geophysical data, of which Nigeria has a lot of, which is, I would call it public domain type data, which can be used in a grassroots type exploration process for investigating the mineral and hydrocarbon potential of the entire country of Nigeria. Techno Imaging is based in Salt Lake City, Utah. Very, very beautiful city. You can see the mountains in the background, and they had a ridiculous amount of this winter, broke all records, and finally in Salt Lake, summer has arrived, and there's a complete change of season. Next slide, please. Thank you. Our company was established in 2005 and is a leading global geophysics technology company. We conduct geophysical surveys and provide the world's most advanced 3D imaging solutions for all types of methods, whether the data is collected in the air, the land, marine, even borehole data, for mineral, hydrocarbon, geothermal, hydrogeological, gas, oil, and production. You'll hear me use the term glass earth and I'll give you a bit of an insight as to what Glass Earth is all about. It provides a cutting-edge proprietary data acquisition and imaging system capable of rendering transparent the top several kilometers of the Earth's strata and reveal with precision geological structures beneath. These advances help making highly informed decisions related to the assessment and development of the mineral spectrum, groundwater, and oil and gas reservoirs. Next slide, please. Thank you. We, of course, have a whole suite of software to interpret all this wonderful data. I think you jumped to the slide after the one I was just discussing. If you could go back to the EM Vision slide, which is just before this particular one. Our software package is called EM Vision, and it's been used and is being used for interpretation of all types of multi-physics survey data. And we have a suite of that does inversion of this geophysical data, which can focus and sharpen and refine geological structures. And it can, and this is quite unique, by the way, it can invert data for very, very large surveys, like entire countries. And we've done, for example, the Yukon in Canada and Alaska, which are side by side. We've done that as one huge data set. And we don't have to break it up in little pieces. So what we're proposing even for Nigeria on a countrywide basis, if not countrywide, maybe a regional basis, interpret the data and produce 3D Earth models of the subsurface for a variety of applications. Next. So Glass Earth, what's that all about? System integration of geophysical survey data. It involves that simultaneous analysis and inversion of multiple data sets and advanced imaging algorithms capable of rendering transparent the top kilometers of the Earth's strata and revealing the geological formation hidden within. I'll give you examples of that later in the presentation. Next. I won't dwell on this slide, but this is presented simply to show you that the technique is patent protected. And in these patents, there's a brief overview of the technology which is used. And our chairman, Michael Zhadanoff, and I'll quickly go through his resume at the end of the talk, has authored or co-authored all of these patents. And there's a lot of good information, which is public domain and in technical papers, giving an overview of our technology, our very unique technology. Next slide, please. And in this particular slide, Technoimaging's technology provides cutting-edge software and is capable of rendering the top several meters down to kilometers of the Earth's strata and reveal with precision geological structures for a variety of applications. Next. We do a lot of work in Saudi Arabia, both for instrument design and for oil and gas exploration. In fact, our chairman is a senior advisor to the Saudi government on a number of different projects. And we conducted this pilot project in Saudi in conjunction with the King Abdulaziz City for Science and Technology. And we've identified a dozen potential mining targets over the study, which were previously unknown to the Saudi government. Next. Here's a project from Canada, which is where I am, north of Toronto, and it's the Kamoskosia Multi-Physics Airborne Survey Area. And the data that were acquired were gravity, airborne gravity, gradiometer data called AGG, and airborne mag data, radiometric data, and EM data. And in the next slide, we will show you an example. Next. And this is a layer or a 3D model, if you like, of the time domain EM data. And we're plotting here the resistivity of the ground. And that's a 3D representation, a 3D voxel model of the entire data set. Next slide, please. And here is another slice of information, if you like, and you can see that the superficial material has been removed from this, and we're seeing beneath the Earth's surface, if you like, and looking for structures that are buried at depth. Next slide. And finally, in this particular slide, again, we've created what we call a glass Earth model, and we're mapping conductive zones at depth, which are, for the most part, mineralized zones, which can be massive sulfides, nickel deposits, et cetera. So we've removed the effect of all the near surface material, and we've discovered some very, very interesting targets at depth, which can be drilled and or maybe some other more detailed surveys carried out before we actually get to the drilling stage. Next slide, please. And here's what we call a towed streamer EM survey, where a ship has what we call a current dipole, if you like, an 800 meter separated current dipole, and a large amount of current is pumped into it. And it makes it possible to collect EM data with a high production rate and over a very large survey area. And beneath it, we have a seismic section, and the colors on the seismic section were derived from the EM data. The EM data was inverted and overlain on the seismic profile, and then you can actually assign geologic units to the various features that are picked up on the seismic survey. Next. And here's an example from the Gulf of Mexico. And the vertical section, it shows a vertical section at the top and a 3D view of the inverse model of the resistivity superimposed on seismics. And you can see how the salt dome is mapped extremely accurate in 3D, and that's very, very useful from an exploration viewpoint. Next. So the power of the TI approach derives from the joint inversion of multiple data sets, which yield a more robust characterization of the subsurface. The process is substantially more powerful than the results provided by any individual data set alone due to the constraints provided by the additional data sets. An oil discovery with its characteristic response signature immediately enables the evaluation of the entire exploration area for comparable features based on the results of the joint inversions. Optimized 3D seismic surveys can then be acquired to mature those prospects for drilling. The 3D joint inversions can be repeated, but now including the information derived from the 3D seismic data to obtain an even more refined and accurate model of the subsurface. The approach provides a powerful methodology for risk reduction, and it is a capability which TI alone possesses, given its patented technology and extensive expertise in its application. Next slide. And here's an example of an African rift structure. And the rift basin holds significant oil reserves. The extensional rift process produces horst and graben structures with high total organic carbon source rocks preserved in the grabens. With burial and thermal maturation, oil migrates up into the reservoir rocks on the horse blocks. Because many of the traps are basement structure associated, airborne gravity and magnetic surveys are a powerful exploration tool. Next. And in this particular case, the rift basin structure from regional gravity, the survey example is from an onshore African rift basin with oil discoveries made on the basement highs, the horsts, and marginal wells on the flanks and dry holes in the grabens. In another onshore rift basin, 28 sequential oil discoveries were made using advanced inversion procedures applied to the FTG data. The only dry hole was drilled without benefit of the FTG inverted maps. Next. And progressing the exploration process in a rift basin study area, on the left side, the structures are from airborne surveys, and on the right side, hydrocarbon presence validation. So the ideal exploration process is conceptually illustrated above. It's a high grading methodology using suitably selected surveys with robust processing inversion procedures to retain only those prospects with the highest probability of success. This approach will also enable building in a prospect seriatim based on estimated reserve potential for drilling. So what we're proposing here is basically to look at, for example, the frontier basins of Nigeria and interpret these structures from existing airborne geophysical data. And Nigeria has complete coverage of aeromag data at a 500-meter line spacing. In fact, there's 2 million line kilometers covering the entire area, which is of the order of 1 million square kilometers. So what we're proposing is to select areas that are, let's say, priority areas by the government, the frontier areas for oil and gas, do our structural interpretation from existing airborne geophysics, not only the MAG, but if there's also, and we believe there is also gravity surveys, gradiometer gravity surveys, and we can select these structures from the airborne geophysics, and then these can be validated using by the techniques that the previous authors discussed, the NXT and the geochemical methods and so on, to validate which ones should actually be drilled in the future and seismic data done. So in a nutshell, it's a way of risk reduction versus, how do you tackle a huge area with frontier basins, on a macro scale. Well, you can do a very inexpensive interpretation of existing data and then go to the next step and validate our targets and reduce risk. Next. And finally, there's an example here from a geothermal problem in Japan. And basically, again, we're unraveling the geology of the subsurface, which can be compared with seismics, and then targets can be selected. We can, for example, map the subsurface geology using the existing seismic as well as inverting the data. Next. So the Glass Earth Nigeria project, what we're proposing is conduct comprehensive analysis and study of existing and relative geophysical data, of which there are many types of data sets, and conduct multi-sensor surveys not previously conducted over highly prospective areas for oil and gas and mineral surveys. And the multi-sensor surveys may include not only magnetics, but EM, full tensor gradiometry, etc. And we would utilize the newly collected data to produce industry highest resolution 3D models of the subsurface geology and identify in more detailed areas of interest. Next. And I alluded to the Frontier Basin project, and without going through all the steps and stages, but on this map on the right, these are the well-known frontier basins of Nigeria. And we have actually proposed to the government of Nigeria to carry out a pilot glass Earth survey, which would be financed by us for the pilot project. And our suggested area would be the Gongola Basin, the Kulmani oil field, and that would provide a degree of confidence and so on the utility of using your existing data to identify areas of interest, which would be further followed up. And as we can see from the previous speaker, there's been surveys already done, which could be compared also with our geophysical interpretation. It would be an excellent study to demonstrate the applicability of what we're proposing as a first step. Next. Nigeria is well endowed, not just with oil and gas, both onshore and offshore, but it also has a huge potential to upscale, if you like, the mining industry. And, you know, I mentioned in the previous slides about doing a pilot project for oil and gas. Well, we've already done one for lithium exploration. And next slide, please. And that pilot project was actually done by for the Geological Survey, and it was focused around lithium. Lithium now is the flavor of the month, of course, and there's surveys being done and studies being done all over the place, including Ghana, where we just completed another lithium project. And our pilot project in Nigeria was extremely successful. And we used a combination of magnetics and radiometrics. And on the three panels below, the circle area represents a potential lithium target, which we identified in our pilot study as a mag low and a thorium low and a potassium high. And we can map pegmatites and differentiate between granitic rocks and pegmatites by using a combination of these two techniques. So it's extremely powerful. And it's absolutely amazing that we could pick this up using 500-meter line spacing surveys. And a lot more can be done by doing more detailed mag surveys and so on. But you can imagine how powerful this could be for looking at different commodities throughout, the entire country of Nigeria, and how much that would attract investment, not only in the oil and gas sector, but in the mineral sector. It's really exciting. Next slide, please. Next, these are a partial list of countries and clients we've worked for in the past. Next slide. We're just about done. And I would be really amiss not to mention our distinguished chairman, Professor Michael Zhadanoff. who's a professor at the University of Utah, and he founded Technoimaging. And he's extremely well known, both in the academic community and for the number of commercial papers. I mean, he's authored 300 papers, published numerous books, and so on and so forth. So what we're doing is quite unique, and I would certainly attribute the technical expertise of our company to Michael. And unfortunately, he couldn't attend the talk today. He's traveling, and he does a lot of traveling, and he just couldn't make the talk. But that's the end of my presentation. Thank you for your patience in going from slide to slide. That kind of slowed it down. But I think we got through it in a little over 20 minutes anyway.
Thank you very much, Mr. Douglas.
You're welcome. And these, by the way, are a list of the books that he's published that are used in universities and by private industry. You're very, very welcome. And again, thank you for the patience for everybody for my presentation.
Thank you very much. In your words, the technology is quite unique. And I must say it is unique because this technology develops and provides 3D imaging solutions for all land, air, marine, borehole, electromagnetic, and potential field geophysical methods for mineral, geothermal, oil and gas exploration and production, carbon capture even, and storage, environmental monitoring, security, and defense applications. So thank you very much for that lovely presentation.
You're welcome.
Thank you very much to all our speakers, and all our presentations were very educating. So we would like to go straight into the question and answer session, and this session will last for another 15 to 20 minutes, and we are more than happy to answer all the questions.
Sorry, Ayo, thank you so much. Ayo, thank you so much. Just before the Q&A, I will crave the indulgence of all the listeners for us to just have a 1 minute silence. The era of non-conventional started with a very good gentleman that is very, very purposeful, very eager, who actually founded the technology, SFD technology, who incidentally passed away sometimes this year. I'll please crave the indulgence of everybody to observe 1 minute silence for my old good friend, the departed soul, Josles Kisgias, who had gone to be with the Lord. He was very, very passionate about, promoting the frontier bases in the country, but of course, the Lord has a better place for him. So I would like you to count a 1 minute silence for him before we go into the question and answer section. Thank you. Ayo, please take note.
Thank you, sir. May his soul rest in perfect peace.
Amen.
Okay, so we would go into our question and answer session. We have a couple of questions in the chat box, so it shows that we have a lot of interested people here. So we'll take a few questions, and whatever questions we're unable to take for sake of time, we would have those answers directly to your emails. Thank you very much. So we'll take the first two questions, which is for NXT Energy Solutions. We have, what property of the formation does the stress field detection measure, and what processes are done on the data? What are the deliverables, and how do you rank these prospects? Mr. Rashid, please.
Yeah, so it's a good question. So an SFD technology, in fact, investigate subsurface density and stress regime And based on that, properties like density and the stress, we received signal attributes which highlight the area with the conducive to fluid entrapment. Okay, and it's a processing, after acquiring the data set, we apply a processing algorithm, which is similar to any geophysical data processing. We go with the signal or the trace selection to trace editing, and then some formatting of the data, binning the data, and then make it to the grid. Now, one of the slide which out of Gulf of Mexico, where we presented, that is output after the processing of the SFD data, where we produce a probability map out of a grid survey, if we go with the grid survey. However, if we are going with a single line survey, then we go with the signal attributes purely with the reservoir extent based on the density and the stress properties of the subsurface. And also on top of that, we provide area of interest. Okay, and I think I was reading some of the questions, and I will connect with through that one as well. Like what SFD does is SFD investigate the entire sedimentary column, whatever is on the top of the basement. That's the depth of the investigation, the top of the basement for SFD. Also, SFD recommended areas over like onshore, offshore, marsh area, and we don't have any really restrictions on the geographical domain. As far as the area is prospective and known to be like a geologically active, I mean, it has a source rock, its a migration is there, reservoir extent or reservoir presence is there, we acquire the data set. Okay. And I think I was reading the question, so I'm trying to connect as much as I can, and then we can also reply on email. There was a question on the success, because reason why we presented the success criteria right now on the presentation, because we want to showcase the success stories. But however, as everyone noticed on one of our slide, where client drilled 28 of SFD recommendation, and out of those 28, 19 were successful. So overall prediction strength is 75%. Okay.
Thank you very much, Mr. Rashid. I will take a few questions from Mr. Rick.
Yes, ma'am.
Okay, so there's a question in the chat box say this technology seems to work only in conjunction with the conventional exploration tools or known areas. Is it more of a reservoir production monitoring tool?
It actually does reservoir monitoring and prediction very, very accurately. It actually has a broad encompass of applications, though. We've done quite a few frontier surveys around the world. One of the biggest ones we've done have been in Kenya and Tanzania. And we just use slightly different modeling techniques. So it's not relegated to simply field production, but it's used in frontier surveys and environmental applications, CO2 monitoring. It has a diverse applicability.
Thank you very much. We have another question. Is the assumption that the micro sea pages travel vertically upward without any deviation in their travel path? How do you separate sea page that is influenced by high porosity from the sea page detection from the abundance of hydrocarbon?
That's a great question. We've been doing this for probably 20 to 25 years. There have been some papers written on microseepage back in the 80s that indicate that microseepage is essentially vertical. Our data has shown that it can vary, basically 100 meters to one direction or the other, sometimes 150 meters, but it typically doesn't vary more than that, simply because of the fact it's moving along a tortuous path of grain boundaries and microfractures. So by definition, that in the mechanism that drives it is buoyancy, microbuoyancy. So by definition, that mechanism essentially limits it to vertical transport.
Thank you very much. We'll take some questions for you, Mr. Douglas. So the first question is there any way the risks associated with this technology can be controlled or taken care of?
The risk associated with the technology. I don't think there's any risk involved with the technology. I'm just trying to figure out what you mean from that. Basically, as a first pass, if you're using data that already exists, then it's a matter of interpreting the data and using multiple parameter data sets. I suppose if one were to just to look at one particular data set, for example, in the lithium problem, let me maybe make it far more practical. The risk was mitigated in the analysis of and exploration of lithium by using two parameters, radiometrics and magnetics. If you just inverted magnetic data, you'd be looking at any granitic rock, whether it's a pegmatite or not. And by bringing in the radiometrics, where you have a high ratio of potassium to thorium over pegmatites, so we're looking for two things. We're looking for magnetic lows, which are produced by granitic type rock, whether they're pegmatites or not, as well as the high ratios, and that really nailed it, if you like. So multiple parameter data sets, or multi-physics, if you like, really does mitigate the risk.
Thank you very much.
You're welcome.
Another question for you, Mr. Douglas. So besides lithium, what other critical metal does glass earth imaging identify?
Oh, whatever mineral you're looking for. They all have a variety of geophysical signatures. For example, in Nigeria, the Benue Trough has really good, high quality lead zinc deposits, very good potential for lead zinc deposits. And that's an easier target to pick up than lithium, using a combination of magnetics and electromagnetics. For gold, we indirectly detect gold, looking at structures, cross-cutting structures. For example, the largest gold producing country in Africa is Ghana. And we flew the gold belts of Ghana. I actually put together most of these regional surveys with modern geophysics dating back to the mid-90s. And the first country I looked at was Ghana, and we did a non-exclusive survey over the gold belts of Ghana. And finding gold is all about structures, 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 because gold is the most difficult commodity to pick up, but we find it in an indirect way by mapping structures. And the same in Nigeria. In Ghana, the predominant structures were northeast, southwest. And we look for cross-cutting features. We look for potassic alteration with the radiometrics. Nickel is another ideal target for electromagnetics. Nickel deposits are, I would say, almost infinitely conducting. And with modern electromagnetic techniques, we can find nickel deposits down hundreds and hundreds of meters. So each of these commodities has their own unique geophysical signatures. So we can help a lot in stimulating, or at least I'll even be so bold, and I don't know whether this will create controversy. Nigeria is at its infancy in minerals. There's no doubt about that. The focus over the years has been looking for oil, offshore, onshore, and so on. And I actually sat down with the president of Nigeria around the year 2000, and we discussed, I explained to him how useful it would be to fly the whole country. And when I was with Fugro, we started off flying the Ogun State because President Obasanjo is from Ogun State, so that suddenly became top priority. But we branched out from that, and the government of Nigeria gave Fugro a very large contract to fly maybe 20, 30% of the country. And then the World Bank came in and financed the remainder of it. So all of Nigeria has excellent airborne geophysical data. And so that data should be utilized and should be looked at in detail. More detailed surveys should be flown. Other type surveys that can target commodities like nickel, lead, zinc, and so on could be flown. And I think that would really attract mineral investment in Nigeria. Nothing drives an interest in exploration in the mining business than discoveries. I think it would be a tremendous way to diversify Nigeria's economy by, focusing on minerals and looking at the old data, interpreting it, and getting mining companies interested in exploring in Nigeria and putting mines into production and creating employment.
Thank you very much, Mr.
You're
Douglas.
welcome.
The next question is for you, Mr. Rashid, and it borders around the environment, the ecosystem. So how does non-seismic SFD technology address environmental concerns or minimize the impact on ecosystems compared to conventional seismic methods?
Yeah, thank you. Yeah, so as a SFD is an airborne geophysical tool, so we don't need any really ground facility to accept apart from the airport. And how we, in fact, if compared to the seismic, what we do, seismic, we optimize the seismic coverage in the area because it's an independent tool which can be utilized to fly first in the area and highlight the prospect area instead of running a regional seismic line and then go from regional to a focus seismic. So that will have a more ground impact. If you go with the complementary tool like SFD and identify the prospective area and then optimize your seismic placement based on the SFD recommendation over a most prospective area, that will definitely reduce the environmental footprints in the region. But as far as SFD concerned, SFD is like environmentally protective tool. It's airborne and doesn't need any ground involvement or ground facilities or ground sensor implantations. Yeah.
Thank you very much. For the sake of time, we'll take just 2 more questions. And we have one question for you, Mr. Rick. How applicable is this technology to offshore fields? Also, can it be deployed for green fields?
Yeah, a large part of our work comes from offshore technologies. Typically, that involves either field development or frontier areas. We're doing quite a few, actually, consecutively right now, one in the Red Sea, 2 in Indonesia, and 1 off of Colombia. And typically what's involved in that is you have a vessel that takes piston cores. We get a slice of those piston cores, and we then enable and analyze those much as we do any sample that's been on the ground. We take those piston cores that are placed in a jar. We put our module in the jar so we can measure the headspace, and then we do studies like that. We did a project offshore South America a couple of years ago where their client had selected a very high resolution 3D seismic program, and they said our data matched incredibly well with where they found structures, And what they found the most interesting was where we got the highest intensities, that's where they saw the largest structures, and where our intensities from the seabed samples began to taper out, that was, or decline, that's where the structures pinched out. So obviously you have less pressure, less hydrocarbon richness. Our results decreased in conjunction with that, spot on. So yes, we do quite a bit of offshore work. I should also mention, since I didn't really speak of it much because the focus here is marginal fields, but we also do a huge amount of work environmentally around the world. Part of that is because of our sensitivity. The other part is because once you pull our modules out of the ground, you don't have to meet holding times anymore for EPA regulations or regulations within various regulatory bodies. So we've actually been doing environmental sampling and detection for 25 years now. We also do mineral detection, as you guys have been talking about that. Douglas has talked about that. A lot of these minerals form organic complexes, which allows us to very accurately monitor them. And we're doing we've been doing work for that for about the last 10 years. So we're involved in those programs as well. But, you know, obviously for the time crunch, I didn't talk about those today.
Thank you very much, Mr. Rick. Also, we have one more question for Mr. Douglas, and it says, will there be a UI design for an onboarding screen for those who want to follow and log into to know this technology?
Thank you, Rick. I went to the muted. No, probably in a nutshell, I would suggest you go to our website. We give a list of many, many papers, technical papers, on case histories and applications, you know, of our technology. And there's also one-pagers summarizing a variety of applications as well. So it probably would be best you go to the website. I would also, you know, encourage you to send an email. And I don't know whether PE Energy has provided our details to this large audience. But certainly, if you have any questions, technical questions, I'd be delighted to answer emails from people in the audience.
Thank you very much, Mr. Douglas. I think it's important for us to note that the work we've done with NGSA in the country for lithium was done with PE Energy, who's our affiliate company, a spin-off where Synergy EMP came out from. So we have done a lot of work synergizing with these technologies. Thank you very much, everyone, for your questions, and for the questions that were not asked or answered. We will definitely reach out to you via email with the responses to your questions. At this point, I would like to introduce one of our advisory board members who would be giving us a closing remark. Mrs. Kalista Azobu, over to you, ma.
Thank you very much. Ayo, I hope you can hear me.
Yes, ma.
Very well.
Okay. I want to stand on the existing protocols. It seems that I might have a camera issue, but I was introduced at the beginning of the program. So it's been really wonderful. On behalf of Synergy EMP, PE Energy, they are members of a panel group of companies and the board. We really appreciate immensely the attendance and participation of all the invited companies and organizations at today's webinar. It's so elating to see the impact the non-conventional data acquisition tools and are making in the energy industry. I recall about 15 years ago, I was told that you never know what is underground until you drill. And that's why, I mean, how did that come about? That's how you find out that so much work was done pre-drilling, but at the end of the day, we still ended up finding, nothing or having what we call dry holes. Now, the accuracy has increased a lot, improved a lot, and these non-conventional solutions that we have from our partners, NXT, that's the FSD solution, and then you have the amplified chemical imaging, and then we also have the presentation made by Techno Imaging. It's wonderful. Just imagine the fact that your accuracy level increases by about 94.5%. That's a lot. And we know what that means. The finding cost of oil decreases. And I can see some percentages here also, about from 60% and above. That's great, because that's the finding cost most of the time in most regimes hits the profit and loss. And we know what that means in terms of returns for investors, and the value of maybe the stock in the markets. So these are really very interesting developments for us in the energy industry, the oil and gas industry, whichever ones we prefer to refer to. So we want to really thank specially the regulators. We have the NUPRC, the NMPC Limited, the NMDPRA, the NCDMB. These are and also various multinationals who are also participating in these activities. We really recognize specially all our special invitees to this webinar. And we want to also thank our partners and the paper presenters. You did a great job. It's so wonderful to see the developments and the achievements that we can make using these non-conventional data methods. And I want to also acknowledge and appreciate our internal team who have anchored this webinar so perfectly. We thank you and we appreciate all that you've done. The ICT team that are usually in the background, we thank you. And most importantly, we want to remind all of us that Synergy EMP or PE Energy, they are available for any questions, for your comments, for further discussions, and really, really to support you in improving the results of your surveys, whether they are exploration or drilling or other mining activities. We are available to support you using these technologies and working with our partners. And on this note, I want to really appreciate your time, your efforts, your participation at this webinar. Thank you so much, and we look forward to hearing from you very soon on your feedbacks, on your needs, and on whatever you may want to maybe understand more regarding these technologies. Thank you, Ayo. I hand over to you. Thank you very much.
Thank you very much, Ma. And I would like to hand over to Mr. Dario Kobo, our Group Managing Director. Over to you, sir.
Thank you, Ayo. It is indeed a great pleasure. I will first and foremost acknowledge the gift of God. It is my singular desire to actually improve the standard of activities in the country. But a dream without a deadline is a nightmare. And what we have decided to do is actually to split activities into what we call the upstream business activities by PE Energy, which was founded in 2009. Today, the company employs both PE Energy, Synergy EMP, and of course, AKD Digital Solution employs over 120 people. And we are breaking serious ground. In 2019, when I wrote to the President of Federal Republic of Nigeria, and he was very glad to invite us to do this presentation with NXT. Last year, we also wrote to the Geological Association body that Dr. Fisher was talking about, the NGSA. And I challenged them. I brought out a fund to make that project, and I think it is going to be a landmark project for the Federal Republic of Nigeria as we begin to diversify our economy. Today, we are actually introducing a lot of technology as we begin to digress into gas. We are looking at zero carbon emission and the rest of them. And we have signed the Paris Agreement. Our company is really, we've employed 2 PhDs. We've employed 2 PhDs in the midst. They are listening. And some of these tools, we're also having a lot of alliances with the UK government. Some of these tools will actually help in addressing the energy security of our dear nation, and also to diversify our economy, to look at the ecological activities below the ground, like my board member has already said. We are a company of high reputation. As you can see, we have a solid board. And after this call, we will respond to all of you. We've done it again and again, and we want to make sure that we build a very reputable organization that will support the industry. We are doing a lot with the authorities, and the members of the authorities are here. Without mentioning your name, I want to thank the CCE of the Nigerian Upstream Petroleum Regulatory Authority, Engineer Komolafe. I'd like to thank him because I introduced this to him, and they've received it with very ample, applause. I also want to thank my mentor, Mele Kiari. I just received a message from him that he was busy, but I think his members of the NNPC Limited are here. And again, I will not repeat what my board member have said, but you have made me proud today. Thank you, everybody, for making or listening to our stories. And then we'll come back with more regards, and then we need your patronage to be able to unveil and to have quick access to your hydrocarbon resources, or I will recently call it petroleum resources. Thank you, and God bless you, and have a great day.
Before we depart,
Thank you very much, sir.
I'd like to thank all the people at Synergy E&P for the opportunity to present today. All of us speakers were honored to be here today, and what a fantastic organization to work with. And so thank you for all your time and effort for setting all of us up. I know it's a lot of work.
Yeah, thank you. Thank you very much for Synergy E&P.
Thank you. Okay.
Thank you.
Thank you, everyone.
Yeah.
Thank you for coming. We look forward to hearing from you.